Your MCP server has powerful prompt templates, but how do you actually use them in your client code? We'll see exactly how to list available prompts and render them with dynamic data, all through FastMCP's clean Async interface. You'll get the rendered messages ready for immediate use with just 2 simple method calls.
Async with client. Hash list available prompts. Prompts equals await client list prompts. Hash get a rendered prompt. Messages equals await client. Get prompt. Analyze data. Data 1, 2, 3. Print messages.
This demonstrates the client-server interaction pattern through a protocol abstraction layer. The FastMCP client acts as a deterministic interface to remote capabilities, exposing tools, resources, and prompts as first-class operations while handling connection management and protocol details automatically. What makes this distinctive is its separation between the protocol operations, what you can do, and transport mechanisms, how you connect, enabling consistent code regardless of whether you're testing locally or connecting to a remote server. The pattern works by establishing a context-managed session where all operations become available after initialization. The client automatically infers the appropriate transport based on the server source, then handles connection lifecycle, capability negotiation, and operation dispatch through a unified interface. This design enables you to write transport-agnostic code that works identically against in-memory servers during testing, local scripts during development, or HTTP endpoints in production. This approach matters because it eliminates the accidental complexity of networked applications. You avoid writing custom connection logic, retry handling, or protocol serialization for each server interaction. The pattern is ideal for building reliable integrations with MCP servers, whether you're creating test harnesses, deterministic applications, or foundational layers for agentic systems. The trade-off is explicit control over low-level details, but that's exactly what makes it predictable and maintainable. Let's break it down line by line.
Async with client.
This establishes an async context manager for the client connection. It guarantees proper resource cleanup when the block exits, preventing connection leaks. The pattern is essential for async operations where manual cleanup would be error-prone.
Hash list available prompts. Prompts equals await client list prompts.
This fetches all available prompt templates from the server. Required first step to discover which prompts exist before rendering, eliminating hard-coded dependencies on specific prompt names.
Hash get a rendered prompt. Messages equals await client. Get prompt. Analyze data. Data 1, 2, 3.
This fetches and renders the analyze data prompt template with dynamic input. The dictionary parameter injects runtime data into the prompt, enabling dynamic AI interactions without hard-coded values. Standard pattern for prompt templating in AI workflows.
Print messages.
This outputs the rendered prompt messages from the AI client. The messages attribute contains the final formatted prompt structure, showing exactly what would be sent to the model after variable interpolation. FastMCP prompt pattern. The getPrompt method transforms static templates into dynamic conversations by merging arguments with reusable message structures. Prompt names are global across servers in multi-server clients, unlike tools which require explicit server prefixes. Always validate prompt arguments against the server's expected schema to avoid silent failures.
The prompt that knows no arguments becomes every argument